Hello and welcome to Poly Educated. My name is Hao, and in today's lesson we are going to learn how to factor polynomials into factor form using the remainder and factor theorems. Firstly, we can use long division to factor polynomials. Now, a little review, let us recall how we can use long division to determine the quotient of two numbers. For example, we have 107 divided by 4. So we put 2 multiplied by 4 to get 8, and we subtract these two numbers to get 2. Remember to bring 7 down, and we use 6 multiplied by 4 to get 24. Remember to subtract these two numbers and we get a final remainder of 3. Now, a few key terms to notice is the number we are dividing is called the dividend, and the number we are dividing by is called the divisor. The answer that we get is called the quotient, and the remainder that we get is called the remainder. So we can generalize this into a statement which is the dividend is equal to divisor multiplied by quotient plus remainder. And for this example, we can write the statement as 107 equals 4 multiplied by 26 plus 3. So I hope you can recall how to use long division to factor numbers, because we can also use long division to factor polynomials. For example, let's use long division to solve 11x plus 2x squared plus 12x cubed plus 14 divided by 2 plus 3x. First and foremost, we must look at the degree of x and arrange them from the highest degree to the lowest degree. And remember to do the same for the divisor as well. So now we can focus on the first terms of the dividend and the divisor, and then determine the quotient when these terms are divided. Here, the first term of the dividend is 12x cubed, and the first term of the divisor is 3x. So since 12x cubed divided by 3x is 4x squared, this becomes the first term of the quotient. Multiply 4x squared by 3x and write the answer below the dividend. Make sure that you line up like terms. Subtract this product from the dividend to get negative 6x squared. Now focus on 3x in the divisor, 3x plus 2, and negative 6x squared in the expression, negative 6x squared plus 11x. Determine the quotient when these terms are divided. Since negative 6x squared divided by 3x is negative 2x, we can then multiply negative 2x by the divisor. Remember to write your answer below the last line, making sure that you line up the like terms and then subtract to get 15x. Now repeat the process until the degree of the remainder is less than the degree of the divisor. So we use 5 multiplied by the divisor to get this, and after we subtract we will get 4. Since the divisor is degree 1, the remainder should be a constant. Now all we have to do is to write the multiplication statement that shows how the divisor, dividend, quotient, and the remainder are all related like this. 12x cubed plus 2x squared plus 11x plus 14 equals 3x plus 2 multiplied by 4x squared minus 2x plus 5 plus 4. Now example 2. Use long division to solve negative 2x squared plus 3x cubed plus 4x plus 7 divided by 2x plus x squared. Again, rearrange the equation from the highest degree to the lowest. Notice how this time our divisor has a degree of 2, but don't worry, the process is still the same. So since 3x cubed divided by x squared is 3x, we can then multiply 3x by the divisor to get this and subtract. Remember to bring 4x down, and we repeat the process again until the degree of the remainder is lesser than the degree of the divisor. So as we can see, 20x plus 7 has a degree of 1, which is lesser than the divisor, which has a degree of 2. So we can be sure that this is the remainder and it cannot be divided anymore. So again, we can write the statement as 3x cubed minus 2x squared plus 4x plus 7 equals x squared plus 2x multiplied by 3x minus 8 plus 20x plus 7. Now on to example 3. use long division to solve 4x squared minus 8x plus 3 divided by x plus 2. Now notice how we don't have a x squared term, so we must write it ourselves into the equation. This is to make our calculation more easier to perform. So with that being said, we can just do our long division as usual. So the final answer we should get is 4x squared minus 8x plus 8. Again, remember to write the general statement. Next, we can also use the remainder theorem to factor out a polynomial. This theorem tells us that when a polynomial fx is divided by x minus a, the remainder is equal to fa. However, if the remainder is 0, then xa is a factor of the polynomial. So let us do some examples to understand what this means. First, determine the remainder when x squared minus 11x plus 4 is divided by x minus 3. So as we learned before, we can use the long division method to find the remainder. But what's good about this remainder theorem is it offers us a very quick way to find the remainder of the equation by substituting x into the equation as follows. Notice how the remainder that we get is the same as the final answer that we get after substituting. So this proves the remainder theorem that when x minus 3 is divided into fx, the remainder will be f3, which in this case is negative 20. Next, let us determine the value of k such that when 3x raised to the power 4 plus kx cubed minus 7x squared plus 4 is divided by x minus 2, the remainder is 72. Now, the information that is provided to us is fa equals 72 according to the remainder theorem. So, all we have to do is to substitute 2 into the equation and make it set equal to 72 to get 8k minus 48, which will give us a final answer of k equals 6. Now, on to example 3. When ax cubed plus 2x squared plus bx plus 7 is divided by x plus 2, the remainder is 3. When it is divided by x minus 3, the remainder is negative 2. So the question wants us to find a and b. So first, we set up the two equations using the information given. Remember to simplify both equations. Now, we have a linear system of two equations with two unknowns. And then we can solve this system of equations by substituting the first equation into the second equation to get a value of a equals negative 3. And then we can substitute a into the second equation to find the value of b of 18. Now, the factor theorem is a special case of the remainder theorem because it tells us that x minus a is a factor of fx if and only if fa equals 0. So of course, let's do some examples to understand what this means. Determine whether x minus a is a factor of each polynomial. A. fx equals x to the power of 4 minus 15x cubed plus 2x squared plus 12x minus 10. So let us use the remainder theorem to find out the remainder of this equation. So we will substitute 1 into the equation to get a final answer of negative 10. Now, according to the factor theorem, x minus a is a factor of fx if and only if fa equals 0. So in this case, we get a remainder of negative 10. So x minus a is not a factor of fx because there is a remainder. Now b. gx equals 5x cubed minus 4x squared plus 3x minus 4. Again, we will substitute 1 into the equation using the remainder theorem to find the remainder. And we will get a final answer of 0, which fulfills the factor theorem. So x minus 1 is a factor of gx because there is no remainder. Next, another way that we can factor polynomials is by using the integral zero theorem, which tells us that if ax minus b is a factor of fx, fb over a will equal 0, where b is the factor of the constant in fx and a is the factor of the leading coefficient in fx. For example, the potential factors of 6x cubed minus 5x squared minus 21x minus 10 will be of the form ax minus b. Since a must divide into the leading coefficient, the possible values of a are the factors of 6, which is plus minus 1, plus minus 2, plus minus 3, plus minus 6. And since b must be divided into the constant, the possible values for b are the factors of negative 10, which are plus minus 1, plus minus 2, plus minus 5, and plus minus 10. So now we must plug all these values one by one into the equation to get the final three factors of x plus 1, 2x minus 5, and 3x plus 2. Next, we can also use the sum or difference of cubes. Now, remember that we have learned the difference of squares before, which tells us x squared minus y squared will have the form of x plus y multiplied by x minus y. So here we are introduced to two more new rules, which is the sum of cubes and the difference of cubes. Now, the sum of cubes have a general formula of x cubed plus y cubed will equal to x plus y multiplied by x squared minus xy plus y squared. And the difference of cubes will have a formula of x cubed minus y cubed equals x minus y multiplied by x squared plus xy plus y squared. Of course, we have a few examples to try out. So let us factor the following expressions. A. 27x cubed plus 125. We know that 27 is the cube of 3, and we know that 125 is the cube of 5. So we can simplify the expression into this. Now, we can use the formula of the sum of cubes to further simplify the expression into this. Next, B. 7x raised to the power of 4 plus 448x. First of all, we must divide out the common factor, which in this case is 7x. This leaves us with a difference of cubes, so we can further factor out the difference of cubes into this. Next, C. X raised to the power of 9 minus 512. First of all, we must write the expression as the difference of two cubes, like this, and use the formula to factor out the expression into this. But notice how x raised to the power of 3 minus 8 is also a difference of cubes, so we must factor it further by using the difference of cubes into this. So we must make sure that all of this cannot be further factored anymore using the sum or difference of cubes. Now lastly, D. X raised to the power of 6 minus y raised to the power of 6. Now in this case, we can use the difference of cubes or squares to factor this expression, but I'm going to use the difference of squares first. So we can simplify the expression into this, which gives us the difference of squares, and factor the equation into this. Notice how these two terms are the sum of squares and the difference of squares too. So we can further both of this into this. Lastly, we can also use grouping strategy to factor polynomials. For example, let us factor x raised to the power of 4 minus 6x cubed plus 2x squared minus 12x. First of all, we must group the first two terms and last two terms together, and then divide out the common factors from each binomial, which is x cubed in the first one and 2x in the second one. Then we divide out the common factor of 6 minus x, and remember that we can still further divide out the common factor of x, which leaves us a final answer of this. And that is all. Thank you for watching, and I hope you guys now have a better understanding of how to factor polynomials into the factor form.